Hi everybody. I have had a few requests to work through the nuclear reactions radioactivity questions, and the request was question number 3, so that's over here. It's question number 3. Now questions 3, 4 and 5 are identical. The only thing that's different is the element that's, or the nucleus that's decaying. So I'll just read through question number 3. I've written it over here on the board. So a radium-224 nucleus decays by emitting an alpha particle with kinetic energy 9.132478 times 10 to the power of negative 13 joules and a gamma photon. Now there are 5 things we need to do. First of all, write a nuclear particle equation for this. State what the daughter nucleus is. Calculate the mass deficit, and then the total kinetic energy, which is the energy released, and then the energy of the gamma photon, followed by what's the frequency of the gamma photon. So let's start off with writing the equation for radium. So radium 224, and then I get the extra details from the back of this. So radium is 88, and it emits an alpha particle, which is a helium nucleus, a gamma photon, and that's not it. There will be one more product because the numbers have to add up on the top. So 224 minus 4 is 220, and 88 minus 2 is 86, and element number 86 is radon. Okay, so the daughter nucleus is radon. So that's your answer to A. And then the next one is the total, what is the mass defect and the binding energy. So the mass defect is mass of the reactants minus mass of products. So the mass of the reactant is the mass of radium that's given over here. That is 372.057 minus mass of an alpha particle is 6.64591. The gamma photon has no mass, plus the mass of radon 365.371, and all this is times 10 to the power of negative 27 kilograms. So if I put that into my calculator, I should get an answer, and that answer is 0.04009 times 10 to the power of negative 27 kilograms. Now this is my mass defect. Okay, in order to get the total energy released, so energy released, this is the kinetic energy, I've got to use E equals mc squared. So that's the 0.04009 times 10 to the power of negative 27 times speed of light squared. And what do I get? So I go 0.04009 exponent negative 27 times 9 exponent 16, and I end up with 3.6081 times 10 to the power of negative 12 joules. Now this is the energy of the alpha particle and the gamma ray. These two have got kinetic energy. Now we know the energy of the alpha particle, so the remaining energy is the energy of the gamma photon. So energy, can you see what I'm writing? Yeah. Of gamma photon is, you subtract the two. So 3.0681 times 10 to the power of negative 12 minus this big number, 9.13. I've got to put it all into my calculator, but because I don't have space on the whiteboard, I've just written it, but in my calculator I need to put this whole thing. So this number minus 9.132478 exponent negative 13, and I end up with 2.69485 times 10 to the power of negative 12 joules. Okay, so that's the energy of the gamma photon. So I'm just going to rub out this bit and I'll do the rest on the top. So the energy of a photon is linked to its frequency by the formula E equals hf. So you get E equals hf, or F is equal to E over h, and my E is this number, 2.6948 times 10 to the power of negative 12, and h is what is called Planck's constant. So you divide that by 6.626 times 10 to the power of negative 34. So when I divide that, divided by 6.626 exponent negative 34, I get 4.067 times 10 to the power of 21 hertz, because it's frequency. Okay, so that is that question solved. So that's question number 3, and I hope that helped. Bye for now.